You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Hey everyone, today I am joined by Sanjeev Mohan, and he is a principal at Sanjmo, an independent analyst and research firm. He's a former Gartner Research Vice President of Data and Analytics. He's an author, he's a podcast host, he's a blogger, and he's quite insightful. So Sanjeev, thank you so much for joining today.
Thank you, Alex. That was very, very warm welcome.
Well, wonderful. Well, so Sanjeev, we tried to do a recording, but then my camera battery ran out at the Paris Convention Center. And we had this conversation that turned to the discussion of LLMs as an EXE. And it seems very pertinent for our discussion today about Kubernetes and the future of Kubernetes and the future of cloud-native technologies. One of the insights that I drew from our conversation and conversations with people like Johnny Kieran, MSV, and listening to people who are speaking is that Kubernetes really isn't ready for the data quite yet. It's really not that ready for the data that we're talking about with LLMs. And so I'd like to talk about that and then use that as a hook to talk about the EXE. So I would just love your take on the preparedness of Kubernetes and the cloud native community for data. Because you were saying that really, for example, metadata really just doesn't have a place that we've heard of in the community.
Yep. So, Alex, this is my observation that the Kubernetes community is very much application and infrastructure centric. It's all about DevOps, developers and operations, and how to make development or developer experience be really good and make the whole development process fast, automated, observable, all of those things that come with it. Data is a stateful, heavily stateful space, which means that if a database were to go down, unlike an application, you cannot just say Kubernetes self-heal, wake up this node and restart the database, because you have transactions that could have been in motion. And what happens to those transactions? Your database could be in an inconsistent state if you just automated some of these tasks. So that is the reason why it has taken a long time for the data community to come on board with Kubernetes. Data scientists also were not really the place where Kubernetes CNCF was really focused. And that is because of the velocity of work that the data scientists do is very different from developers. Developers are constantly, provision me a new cluster because I want to test this new feature and things like that. Data scientists moved at a different pace because they were training their models, writing their algorithms, testing it. But today, what's happened is that the pace of data engineers has picked up tremendously. We are constantly trying new AI applications or workloads. So as a result, Kubernetes now has an important role to play in helping the data scientist. Maybe it's not even the data scientist. Actually, it is the new role of AI engineer who is more aware of what resources are being provisioned, how these resources are being consumed. And just to complete what I'm saying, what I'm starting to see is that because LLMs are very expensive to train, GPUs are even more expensive to use. So cost becomes and resource utilization become very, very critical in the AI space. Kubernetes actually has a very interesting role to play because it can help provision these resources, monitor them, observe them. If there's a problem, then you can shut it down or restart. So saving costs becomes really important. and a lot of these new developments that we are starting to see, for example, last week was NVIDIA's GTC conference, and they announced something called NIM, which is NVIDIA Inference Microservices. And NIM is actually a Docker container orchestrated by Kubernetes. And this only happened last week when we were at KubeCon and NVIDIA GTC was going on at the same time. So we are starting to see, you want to create vector embeddings. Here is your Docker container orchestrated by Kubernetes. Brand new development. In fact, when the keynote took place at KubeCon last week, no one even mentioned this because it had literally been hours since this was announced on the other side of the world.
So then let's move to this discussion about the EXE, and that's basically a Microsoft term, right? It's an executable.
Correct.
Right?
Yes.
It's mostly just a symbol for our purposes here, really.
Yeah.
But it sits right in the middle, right? It's and you see that with LangChain, for example. LangChain is, as Johnny Kiram has said, is like the new JDBC. It's like that middleware, right? And I see that kind of similarly so here. So let's get to that hook. How do you see the LLM as that intelligent platform in the middle?
Yes. So why we were talking about LLM as an EXE, although some people may say, well, since LLM is not really executable, so maybe a more apt term, maybe LLM is a new DLL that gets embedded into your workload. So, but the idea is to show how important these LLMs are. In fact, I would even go as far as saying that LLMs are passé. LLMs are a commodity now.
Right.
Today, this morning, Databricks announced DBRX, their new 132 billion parameter model. And my question is really why? I mean, it's with every model, there are improvements. So no question, no doubts about it. So great job that you've come up with this because it's supposed to be cheaper, better, more accurate, not compared to GPT-4, but compared to Llama 2, some other open source models. But we have enough LLMs. What is more important, a bigger ecosystem that is developing right now, and it's only just starting, is that of AI agents. These AI agents are like microservices. These are very business domain specific, task specific programs that sit on top of LLMs, and then they execute a task on behalf of the user. So, Alex, interestingly, although we are trying to draw some parallels by saying LLM is an EXE or a DLL, there is another term being used, which is LLM as an operating system. And so
I've heard that. Yeah,
that seems LLM
OS. That seems more. That seems more correct to me. But
correct.
Before we get to that point, now one thing that I heard at KubeCon is the OS is the role of the OS with hardware. Okay. So it was described by one speaker as the OS extracts from the hardware. And that then brings in context GPUs, doesn't it? And so that becomes then a kind of a hook to understand more what this means. I'm trying to understand what this means as the LLM as an operating system.
Yeah. So it's a confusing space, I have to say, because LLM is the operating system, but then it doesn't have all the libraries. For that, you need another layer on top, like NVIDIA has CUDA, which is all the libraries. So mathematical library, embedding library. So it's actually multi-layered stuff. What is happening? Actually, there's a lot of tension in the industry right now because NVIDIA right now is pretty much a monopoly when it comes to GPUs. Although Intel, AMD, ARM, Qualcomm, AWS with Inferentia and Trainium, Google's TPU, they're all coming out with their own hardware. But then what happens is that on top of this hardware is this SDK, if you may, or this layer, which is CUDA from NVIDIA, and that only works on NVIDIA GPUs. So you're sort of locked into this ecosystem of NVIDIA. So there's this move to actually create third-party vendor-neutral layer on top, and then you've got LLMs. So there's a lot of moving parts in this.
Yeah,
this
there
space.
are a lot of moving parts. And, maybe we can come back to the discussion about KubeCon in a minute and Kubernetes in a minute, but let's drill down a little bit into CUDA.
Mhm.
CUDA is containerized, right? So you can, essentially, Snowflake uses CUDA for using NVIDIA's models. I know that VMware did as well. VMware made an announcement before the acquisition was finalized that they were using
Mhm.
containerized LLMs from the models from NVIDIA. So that's their business, right? They're
Right.
they're containerizing these models, right, that they
Yeah.
can generate. And they do them for all types of different verticals, as we well know, right?
Mhm.
But CUDA also gets its own critiques, right? Because it's fairly old. As I
Yeah, it's
understand,
15 years.
it's 15 years
Yep.
old.
Yep.
And so that brings us back then to the Kubernetes community, right? And what's the open source alternative to CUDA? Is there anything there now? And is that the future that we're going to have to look at for what
Yeah.
this means for Kubernetes and the KubeCon community? Or
Actually,
KubeCon and the
there
Kubernetes
is.
community?
Yeah. So right now there are no alternatives to CUDA, but there's a lot of movement going on. Just a few months ago, Google, Intel, and Qualcomm, they got together and they created something called UXL Foundation, which is actually supposed to be an open source alternative to CUDA. I think it started in September, but it's only now that people have started talking to it. I believe AWS and Azure are also looking into it. So there is this move to create this UXL Foundation, which is the open source alternative to CUDA.
Okay. So let's go back to then Kubernetes then.
Yeah.
And, Kubernetes is for application infrastructure. It's for DevOps.
Yes.
It's for, helping developers push out at scale application development,
Mhm.
management, and development, deployment, and management. That's clear. But it's never been a place for data, really. I mean, we've seen data on Kubernetes. We've seen there's some projects out there that, that relate to data.
Mhm.
But all I really heard about at KubeCon were things like Slurm, which really isn't even a Kubernetes project, right? There's Ray and then K-Ray. There's TeakV, right? There's these different projects that are kind of seem like scattered a bit around, right?
Yeah.
And all we're kind of hearing right now is the hope, right? The hope that we will help, make the data scientist's life more comfortable. Well, what is really going on? What's happening? What is on the what are we going to see?
So there are two ways of looking at Kubernetes and AI. One is Kubernetes for AI, and the other one is AI for Kubernetes. So
Okay.
if I may say, parse this, Kubernetes for AI is what we saw a lot, which is to provision AI workloads. How can Kubernetes be the control plane, if you may? So I can, in fact, we saw NVIDIA was on stage at keynote. They talked about dynamic resource allocation (DRA), where the you can dynamically allocate or sort of fractional GPUs, so that way you can save cost. So that is Kubernetes for AI, and there's a lot of movement, DRA being one of them. YAML, using YAML to declaratively specify what resources you need. All that development is going very well, and I think we're going to see more and more of that, where Kubernetes becomes the control plane for generative AI. The other hand is what I call AI for Kubernetes. That is, what is the role of AI instead of Kubernetes? Like, how is AI going to make Kubernetes be that much more powerful, use LLMs to do some of the stuff? I've not seen a lot on that side. Maybe by next KubeCon or the one after that, we will start seeing a higher integration at the application level as opposed to at the infrastructure level.
Okay, so this is interesting. So the control plane is like, that's like, to me, that seems like very much like no brainer, right?
Yeah.
And that's what we
Yeah.
saw in the beginning of the Kubernetes,
Correct.
establishment as the platform for infrastructure, application infrastructure, and DevOps. No question about it, right?
Yeah.
So it doesn't seem like that's that difficult to then translate that into a control plane for AI, for generative
Yeah.
AI, right?
Correct.
That seems to me like, okay, you can talk about that all day if you like, and I expect that's what OpenAI has done, right? And that's what those
Yep.
those
OpenAI
others have
uses.
established, like,
Yeah.
but that's not the hard part. The hard part is like that developer
Yeah.
who says, here's what I want to do. Here's what, and this Johnny shared this with me, that, I'm a developer. I'm a developer, and I've just read this research paper. I want to test it with a Python-based GPU in a
Correct.
PyTorch environment. Okay.
Mhm.
And so she goes over and asks her engineering team, hey, can I access a Jupyter notebook with 2 GPUs and all my libraries? And they're like, well, that's going to take 3 days,
Yeah.
and that seems to be the crux of the matter right now. And then what
Yeah.
I basically heard from the community is like, yes, that's true. Right. It's going to take you 3 days. And the
Mhm.
problem is data scientists don't know anything about Kubernetes, or they will say, data science doesn't know anything about Kubernetes, but that's okay because it's supposed to be invisible. But
Hmm.
it's starting to protrude. It's starting to, like, you're starting to be able to see the iron almost underneath your feet, because there is this need for the data scientists to really start to build out quickly. So I'm wondering, what are the projects that are going to make
Yeah.
this possible? What is the work that needs to be done? And is Kubernetes even the right place for all this stuff? Is it really,
Yeah.
does it make sense?
So, Alex, you mentioned when we started this that we were planning to record this last week at KubeCon, but we're doing it a few days after
Yeah.
we got back, and things are changing so fast. My answer last week and this week are entirely different,
Right.
because so much has happened since we last met
Right.
that the very question you asked is now, there's an answer for that. So here is the answer. Yesterday, if a developer wanted to try a new AI workload and they went to the IT team said, sorry, it'll take me 3 weeks or 3 days or whatever to procure. And now I'm a data scientist, let's say, and I use things like weights and biases as one of my tools. Weights and biases is very popular in the data
Right.
science community. Well, as of this week, it turns out that I don't have to go to my IT anymore. Now, what I'm going to say can scare, because now the image of shadow IT or shadow AI comes up. But anyway, hear me out. Today, as a data scientist, I can go to a GPU farm in the cloud like CoreWeave. CoreWeave has an application catalog. In the application catalog is weights and biases as a container orchestrated by Kubernetes. Using NVIDIA's new NIM that I just mentioned. So I don't have to wait for my IT anymore. I've got the same weights and biases that I'm used to running on premises or in my environment or my VPC. Now I can use that in a third-party GPU as a service, and I'm off the ground. I can start training or fine-tuning my models. I can do RAG pipelines. So this is how things are. This is the speed at which things are moving today.
So we don't have to wait for Kubernetes, really.
Correct.
We don't
Yep.
have to wait for the cloud native community, really.
That is true. Yes.
I mean, Oracle might get up there and say, we got all these great projects underway, but in the meantime, what you're saying is that these data scientists or AI engineers can just work around it.
That is correct. Yeah.
And they can have all the now. Can they get all the infrastructure support that they need then, so they can fit within their enterprise environment?
Pretty much, yes. That's exactly where we're going. In fact, there are so many companies that are providing a whole complete stack. One of the companies, by the way, that was providing the infrastructure layer, the API layer, the development environment, integration to third-party products is a company called Run.ai. The whole idea of Run.ai was, how do you speed up and accelerate your development of AI applications? Well, guess what? Again, since we last met, we just found out this week that NVIDIA is actually acquiring Run.ai. So NVIDIA is actually moving up from being a chip company into being the entire stack.
Yeah. That's what's happening, aren't we seeing that? So is that an existential threat to the cloud native community?
I don't think it's an existential crisis. I think it's an identity crisis.
Yeah.
What I mean by that is, like, companies have to now figure out, like, what do we do? What part of the stack do we fulfill? So they will exist. I mean, we need these capabilities and functionality, but do we need 5-10 companies to do it? I've heard there are cases where a new Y Combinator cohort starts, and it turns out that a bunch of them are actually addressing the same problem, but they're coming from different angles. But the problem they're trying to solve is the same. So maybe there will be some consolidation, but this industry will grow and prosper and just add more and more functionality. So, but they'll have to figure out, like, where in the stack do they play?
So what are you going to be looking for as we move forward over the next 3 to 6 months?
Okay, great question. I was super excited about LLMs. Now I'm not, because there's just too many. This morning, I went to Hugging Face just to see how many models are there as of today. I think today's number was 569,000 models. So LLMs are becoming a commodity. I am, like I said earlier, I'm very interested in AI agents. But how do you build an AI agent? You need some framework. Microsoft has a framework. OpenAI has a framework. And now, guess what? There are dozens of frameworks. So even frameworks have become passe. I don't, because how do you distinguish? How many frameworks do you need? So my focus for the next year or so is going to be on the business side. How do you align the business use case into the AI space? Like, how do you deliver agents? I think agents, not how, like, the framework, but the end-to-end, which includes governance, evaluating the right model to choose. So that how do you design, build, deploy, and scale an AI agent is going to be, in my mind, the most important thing.
How do you build, design, and scale an AI agent?
Correct.
What are you seeing as a start?
So, companies like Run.ai, for instance, that's what their motive is. Now that they become part of NVIDIA, I'm sure when we go to Google Cloud next, By the way, Snowflake has been very quiet in this space, and I'm sure with this change of leadership there and now being more AI focused, they are working through a Snowpark based solution right now, is my guess. So when we go to Snowflake Summit, Databricks has already thrown down the gauntlet in this space. But even Oracle, Cloudera, Teradata, HP, Dell, all of these companies are probably all barreling towards the same goal of how do you design, build, deploy, and scale AI applications faster and cheaper.
So this is another topic I think we need to discuss another time, because really we could really need to get into agents themselves, because
Yeah.
agents themselves are really the question mark here. Like, how do you build them? How do you design them? How do you monitor them? How do you observe them?
Yep.
How do you, because the LLM environment, or the generative AI, which you're calling is a commodity, is much different. You've got to look at not just the traditional measurements we use in cloud native, but there's a lot of different kinds of more semantic types of things you need to look at, right?
Yep.
Hallucinations and all that kind of stuff.
Yeah.
So this has been really fun, Sanjeev. I really appreciate your time. This is really, really insightful and helpful. Thank you.
So, Alex, it is scary actually to do these videos. I'd be very honest with you, and you don't have to put it in the final product, because you never know, because things are changing so fast. You never know, is this the right track? Because 72 hours later, you find out, oh wait, something new has come up. So
that's okay. In my book, that's okay, because you can keep reminding people that that's the case, right? This stuff is brand new. This is
correct.
And we, as we well know, what takes the first time maybe 10 years to do, the second time it takes 5 years to do.
Correct.
The third time it takes 2.5, and so on, right? So now we're kind of in this phase where we have all the precedent. That precedent means that we can just do things a lot faster.
Yeah.
And that to me is the interesting part of this space now, because one of the great differentiators we've seen over the past 10 years and even previously is how, when this cycle really starts to accelerate, what you see is the ability to take more risk. Because previously you could not take that risk because the project would take too long to do.
Right.
With the ability to, for instance, use WebAssembly and have a difference in, compiling that they have, right? It opens up a giant opportunity for companies that are looking to, like, for instance, be much more efficient with their video distribution. So that's what's interesting now. And so you're really good at what you know. And, in the video, I think is a good place for you, because what you can do is you can just keep talking about it. Keep talking about it.
Correct.
And that's what I really love having you on the show about, and just
thank you so much.
Yeah.
Thank you. Really appreciated this. You really have a knack for asking the right questions and being deep, like not just tell me what's out there. It's why are we doing this stuff? How is it going to impact the future? So thank you so much for guiding.
Sanjeev, I look forward to seeing you soon. Are you going to be at Google Cloud Next?
Yes, I'll be there. Are you going to be there?
Yeah, I believe so.
Okay.
All right. We'll see you soon.
I will see you then. Take care. See you. Thank you. See you. Bye.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.